Structural isomerism. Here we will discuss few lines about structural isomerism. The name itself indicates isomers are the compounds which contain same molecular formula but different structures and properties. Here the structure will be different. It is of different types: chain isomers, position isomers, functional group isomers, metamers, ring chain isomers, and isotopic isomers. Teachers usually take here tautomerism also, but actually tautomerism is not true isomerism, but generally they teach here. We'll go with all these one by one in this small session. First, chain isomerism. Name itself indicates compounds having same molecular formula but different length of the carbon chain. Carbon parent chain length will be different. Correct. So I would like to take the examples like butane. 4 carbon atoms in the chain. 2-methyl propane, or you say isobutane. Both have same formula, C4H10. Example number 2. Pentane. 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4 carbons. 1, 2, 3 carbons. Number of carbon atoms are different. 1, 2, 3, 4, 5, 6. Now I am taking hexane. 1, 2, 3, 4, 5. In all these cases, number of carbon atoms are going to be same in the formula, but number of carbon atoms in the parent chain are different. Then they are called. This is for C5H12. These are the examples for C6H14. Position isomers. Name itself indicates position will be different. Compounds having same molecular formula but different position of functional groups. For example, OH, 1, 2, 3, 4, 1 butanol, and this compound is 2 butanol. Position of functional group is different. Or 1 butene, position of multiple bond is different. 2 butene, compounds having same formula but difference in this. Are substituents 2 chloropropane and 1 chloropropane. So functional group position may be different, multiple bond position may be different, substituent position may be different. In such cases, you can call them as position isomers. If you want more examples, you can take benzene, 2 methyl groups, 1 2 position, 1 3 position, 1 4 position also you can take. This is orthoxylene, this is metaxylene, and this is paraxylene. Correct? Not only this, if you want, you can make some changes. 2 OH groups you can take catechol, 2 OH group at meta position resorcinol, 2 OH groups at para position hydroquinol, or you say quinol. Position isomers. Coming to functional group isomers. Functional group isomers means the compounds having same molecular formula but different functional groups. So this is not possible in all cases. Few examples will be there, like alcohol ethers. CH3, CH2OH, it is alcohol. Ethanol. CH3OCH3, this is methoxymethane. The first one is alcohol, second one is ether. You can take the example of acid and ester. CH3CH2COOH. Propanoic acid, correct? Now I am just making small change here. CH3COOCH3. Formula will be same. You can check methyl ethanoate. I am writing IUPAC name. Acids and esters. Two double bonds and triple bond also you can take. CH2 double bond CH, CH double bond CH2. This is but 1,3-diene. Or you can take simply CH3C triple bond CCH. Butane. Functional groups are different. Cyanides and isocyanides. CH3CN, CH3NC. Like these kind of examples you can take. And most common example is CH3, CH2, CHO. This is propanol aldehyde. CH3C double bond O CH3. This is acetone, ketone, and you can take like this also. Enol, prop 1 in 2 ol. Enols, ketones, and aldehydes. If you want this example, you see, this is C4H8, open chain, and this also C4H8 only, but this is butene, and this is cyclobutane. Functional group is different. This is alkene, here nothing. Okay, now this is cycloalkane. These you can call as ring chain isomers also. One is ring, another is chain. So you can call this type as ring chain isomers. So three types we have discussed: position, functional group, and chain isomerism. One more wonderful is metamers. In metamers, what happens is functional group will be same, but nature of alkyl groups attached will be different. See here, CH2, CH2, CH3. This is ethyl. This is methyl. This is propyl. Functional group is same. C double bond OO. This is the functional group. Here methyl. Here ethyl. C double bond O, functional group. This is ethyl. This is methyl. Name methyl propanoate. Here ethyl ethanoate. These kind of compounds are called metamers. Very interesting example is this one. You can see the last example, 2-pentanone and 3-pentanone. Looks like position isomerism, but here this is the functional group. This side ethyl and ethyl. Here this is the functional group methyl and propyl. When functional groups are different, you can call them as, when functional group is same but alkyl groups are different, then you can call them as metamers. Here functional groups are same, functional groups are same. In this case, better to call them as metamers rather than calling them as position isomers. Metamers. CD4CH4. In place of hydrogen, deuteriums are present. Like this, you can call them as isotopic isomers. Okay, rarely coming. Okay, so important one is, if you take one example C4H10O, we can take all these here. See, C4H10O, OH. If you take like this, these two you can call them as position isomers. These two you can call them as chain isomers. These two you can call them as functional group isomers. These two you can call them as metamers. So all types you can consider here. But position isomers, chain isomers, functional group isomers, and metamers, all these you can take. For this, one more example is possible, that is this one. So total 7 isomers will be there for C4H10O. In that position, chain, functional group and metamers all are available. Thank you. This is your lucky sir.